This is what it looks like from the outside. That's the police lights. Gives you kind of idea of a lot of the many different little patterns that I've got queued up in the little Arduino board. There's one little Arduino running these. All right, we're going to call that quits. This tree has five chains. This is my fire motif. It kind of looks like fire and sparks are going up. And I've got lots of different patterns that play out. All this is controlled by a little Arduino Uno. And each one of these shows may last anywhere from 10 to 60 seconds depending on the show. And it's raining out, so I'm not going to give you much of a show on this. I've clocked that you can get an Arduino Uno to shift out 8 of these chains simultaneously and do all of the different patterns. Sorry, the colors will look washed out in the video because it's overcompensating for the dark background. And there's a whole bunch of different motifs, or shows, I guess you want to call them. Looks like a sparkling diamond, doesn't it? Those are actually all rainbow colors. It looks a little washed out. It's okay. I'm going back inside because it's raining. I'm trying to keep you guys up to date on what's going on and all the different projects I have going on, so you have an appreciation for all the stuff I got to do. One of the things I'm doing is improving the kitchen. The light fixture burned out. The light above the sink burned out. Oh, I'm going to guess about a year ago, and I've been trying to find something and decided I'm going to do my own thing here. Also, up above, I have this LED chain that I just have draped up there to give indirect lighting to the gable. And that works not too bad, but I want something that changes color, so I'm going to be using some LED chains. The LED chains, multicolored chains that are programmable, have come down a lot in price. Let's go out to the garage. I'm going to open the garage door. So what I've got for the kitchen above the sink, Okay, I'm working on a frame here with a plexiglass cover, and the inside is going to be painted black. And what's going to be in there is this LED tricolor chain here. You can get these strips of 300 LEDs. Each LED is individually programmable. You can get these a 5-meter chain of this for about $50. You can also get it in the plastic sheathed version if you want to use them outside. And to give you an example, the reason why I open the door is what I have on my tree out here. I call this my burning bush. And that's beautiful up here in the mountains. Normally it's 8 degrees out. We've had 50-degree weather this entire week so far. Okay, this is the chain I have up over the kitchen right now. I am going to switch to these so I can control the indirect lighting. And here's the Arduino Uno. That little board running a 16 megahertz AVR processor can actually handle up to 8 simultaneous chains. It's pretty impressive. The purpose of using the LED chains, these are my window inserts for my gable windows. I'm using the high density LED chains, and I got the Arduino driving them. The Arduino is going to drive all 4 windows. There's 6 windows in the gable, but I only had time to make enough frame inserts for 4 because I have other things of more importance I need to do, but this is one of the little things I wanted to get done. This is the motif, or the little show that I call comets. That's police lights. And so there's a lot of different shows that I've programmed into the Arduino. This is like a rainbow that's just pumping around the outside. I'm having way too much fun with this. So I got to put these up in the window, all 4 of them. I got 2 more over here that I'm almost finished with. These 2 are done. They're ready to be put into the window. Here we're going full white. You can see that I've got enough power out that we're not getting any red shift in any of the LEDs, which means I've got good power. Where I have power coming in at one corner, but I got power going around a loop, so there's no more than 75 chains in any one direction from where the power comes in. Anyway, this is what the kitchen light looks installed above the sink. It's still going through its Christmas type motif, but for now, until I get things worked out, that's what I'm having. And there's what the frames. I've got 4 of the 6 gable windows because I ran out of lumber. This is a comparative analysis of the LED light chains that you can get from Amazon. Most of these chains are produced in China, and there's a lot of difference in variety and quality. So hopefully this video will help those other people out that are trying to make a project with these LED light chains and give them some tips on what to look for and the different variety and the different controlling schemes. There are 3 basic types of controllers. The WS2811, which includes the WS2812. The WS2812, okay, the WS2812 is basically a controller is in the IC controller is actually in the LED. You can see a little black dot in the upper left-hand corner of the LED. That's the 28. That whole assembly is called the 2812. Whereas the 2811 is an individual IC. But these 2 chips work on the same controlling principle. Then you have the TM1803, and I only have one example of a TM1803. This is the device this is the strip you can get from Radio Shack, or could get from Radio Shack. In this particular configuration, each device controls 3 LEDs, and you can see here, this is where you can clip the chains to get individual controlling units out. And you can see there's 1 controlling chip and 3 RGB LEDs. The other controller is the LPD6803. This is actually the easiest one to control. This one is very, very easy to put into an Arduino. The difference is these two over here, the 2800 series and the 1803 series, require pulse width modulation to properly encode the RGB signal out. The 6803 has a clock signal, which allows you a lot of leeway in timing characteristics. But again, this configuration is 3 LEDs per controlling chip. There's the controlling chip, there's the 3 LEDs, and there you can see the separation point between the individual little printed circuit boards. The 6003 does 16 or 15-bit color. That's 5 bits for red, green, and blue. The TM1803 does 24-bit, which is 8 bits for red, green, and blue. And the 2812 also does 24-bit, which is 8 bits for red, green, and blue. The difference in the variety of the boards out there is the printed circuit boards can come in either black printed circuit board or white printed circuit board. I don't know if it really makes that much difference. The number of LEDs per meter, there's usually 2 different sizes I've found. This one here is 60 LEDs per meter, where this one over here as you can see, this one over here is 30 LEDs per meter. Okay. The other difference is some you can get in a plastic sheath that allows you to use them outside. You can kind of see the plastic sheath, which isn't too bad. It's pretty durable. And then you get the others, which are just bare printed circuit board. Usually they come with an adhesive strip, a peel-off adhesive strip on the back, which allows mounting easy. But the problem I found with the adhesive strip is it doesn't really stick that well, and your projects will eventually come apart. It's not really that good. Okay, and the other thing is the power options. The 6803 and the 1803 require 12 volts to power the LEDs, which is nice, and I'll show you why in a minute. The 2812 and the 2811 require 5 volts to power, and I'll show you the problem with that right now. I'm going to put the camera up on the mount, and what we have here is we have a 5 volt power supply driving a 2812 chain. It's a 5 meter chain, 15 foot. It goes all the way out to the edge of the garage there. Okay, and I'm going to show you the problem with the 5 volt chains. Let me turn the power on. And this is what I call the red shift. Okay, when the Arduino powers up here, I'm just sending out a white pulse from one end of the chain to the other and back. And now it's going to come back. And now we're going to continually infuse white all the way down the end of the chain. And you can see as it starts to get, it's past 2 meters now, and it gets farther along, you can see the color is changing. It's probably hard to see in the camera. Let me take the camera off. The color of the LEDs are shifting from white near the power supply to red all the way out to the end. The reason for that is that the printed circuit boards cannot maintain the current needed in the printed circuit board to supply the power needed for the green and the blue. In other words, the red LED can glow at lower voltages, where the green and the blue LED, they need higher voltage to turn on. And what's happening is the 5 volt power is dropping because of the resistance and the power consumption earlier in the chain. And that's why, so the problem you're going to run into with these chains is that the safe limit for control, we're starting to dim now. See, as we dim, it's turning white. Now it's getting into the playful modes of the, let me start that again because I need to get it's the 75 LED mark is where you can power a chain out using a 5 volt supply where the color white will remain white. So, anyway, it's starting to go into its playful mode now. Starting to send colors out. So we're driving this from a Arduino Uno. That is the controller we're using. Okay, if you don't have full capacity, if you're not driving it to full white, you can get the colors to be vibrant all the way to the end, as long as you're not pulling enough, if you're not pulling full power along the length of the chain, then you can drive it longer on 5 volts. So, I tell you, I've had a lot of fun with these things. I want to find a reason to use them in my experiments as like indicators or something. Right now, the only reason I'm spending time on this is because I wanted to put up Christmas lights this year. And I wanted to do something a little bit more fancy than what I've ever done before. All right, I'm not going to do the 12 volt. These 12 volt chains work pretty good for long distances. I've had entire chains, even 2 chains bound together end to end, and I did not see any degradation. It's a lot easier to transmit the 12 volts down a long line than it is the 5 volts. Because with the 12 volts, you're going to be sending voltage, a lot less current to get the same effect. So there's no real problem with the power. And I wish, the best combination would be the 12 volt drive with the 2812, which gives you only need 1 line to drive it, where the 6803 requires 2 lines to drive it. You need a data line and a clock line. Where the 2812, all you need is 1 line, but then you have to do some fancy pulse width modulation to get the data across. Oh, there's my police. We're sending a rainbow out. It's pretty cool stuff, actually. All right, and I had to write my own software for both the 2812 and the 6803 because the software that's out there is very buggy and it's very poorly written and it's very inefficient. With the little Arduino Uno, I can pump out 8 chains simultaneously, either of the 2812 or the 6803 type. So the length of the chain doesn't really matter, except that we run out of memory, because what I do is I run a pixel buffer where you basically write into the pixel buffer what you want to appear on the chain, and then you tell the Arduino to show it, and it'll run the pattern all the way down the length of the chain, and it can drive the chains at 60 cycles, meaning you can update the entire length of the chain of a 300 LED chain at a 60 cycle rate, and it's pretty darn good. It took me a long time sitting over an oscilloscope to get the timing just right for that. So anyway, this is the comparison again. You've got the 24-bit 5 volt drive type, and the 2811 is the individual controller chip. The 2812, that's the chip built into a 5050 LED. Then you have the 1803, which is an individual controller chip, and the 6803, which is another individual controller chip. These guys are set up to run 3 LEDs per chip. So when you command this little section right here, this is 1 pixel. These 3 LEDs are treated as 1 pixel. When you set the brightness for this pixel, all 3 of these LEDs are lit up the same. So that's about all I can think of as far as the difference between all these chains, and they're not really that bad. The colors could be better. This is the one from Radio Shack. In my opinion, this one has the most vibrant colors. I think they've paid more attention to buffering and filtering and protection of the circuitry when you see all the extra little chips they have in there. The problem, though, is for this one you're going to pay $26 per meter, and that would be 30 LEDs. Whereas this guy right here, this guy is also 30 LEDs per meter, but you're going to pay, I believe it is $40 for a 5 meter chain, and the high density LEDs, which are 60 LEDs per meter, these are about $50 for a 5 meter chain. So for double the cost of this, you can get 5 meters as opposed to 1 meter, and you can get double the density of LEDs. So there's a lot of comparison out there, and again, you get a choice between a black and white controller board, the number of LEDs per meter, whether it's sheathed or unsheathed, and what your controller is and the power options. So and again, the software that's out there is really not well written. So anyway, that's my comparison of LED chains, and I will show you the end result when I get these things put up.